Today we're going to be talking about the third way to solve a system of linear equations. First way was by graphing, and remember, you only want to use graphing when you're really trying to compare all the solutions of each system or of each part of the system, or you want to use it when you want to represent it with like a picture. But other than that, you really don't want to use graphing. The second way was substitution, which we worked on yesterday, and now today is elimination. I want you to hit pause, copy this, then hit play, and I'm going to move it down so you can copy the rest of it that's on the left. Once you've done that, hit pause again, and then hit play when you're ready for me to go over it and start your examples. This is the second part of the left side that I want you to write down, so finish writing that down, and you probably stop somewhere right around here. Hit play when you're ready to go over it. I'm going to go ahead and walk you through what you wrote down on the left side before we start the examples so that you kind of get an idea of what we're going to try to do, and then from there we'll go through the examples and practice it. The main thing is your goal, and your goal is to have one variable cancel by using addition or subtraction. So when you were talking about substitution, your goal was to have one variable go away by plugging in another variable for it, and then you ended up with one variable. Well, this time you're going to try to get one of the variables to cancel by adding or subtracting with the two equations together. All equations need to be in standard form, so ax plus by equals c, where x and y are on the same side, and the variables need to be lined up vertically, and I'll show you what that means, but basically you want your x's in each equation lined up, your y's in each equation lined up, and then your numbers that don't have a variable on the other side lined up. You're going to look for a variable that can be eliminated, which I'll show you, and then you're going to put parentheses around that whole equation, whichever one looks like. It's the bottom equation. You're going to add an addition sign or a subtraction sign in the front of it. Then you're going to add or subtract, whatever you decided to do here, each set of terms. And I'll show you this, but I just want you to kind of get the idea. Hint, when you have opposite signs you're going to add, and when you have the same side you're going to subtract. You solve for the variable that's left. Once one of them cancels, you solve for the one that's left. You use that answer to find the canceled variable, just like you did in substitution. From here over is exactly the same as yesterday. So let's walk through a couple examples so you can kind of see how this works, and we'll go from there. This is example 1. I took away the paper that had everything written on the left because I wanted more space here for me to be able to show you. Write that down. Notice when we were using substitution, a lot of the time I didn't write the equations lined up vertically. I wrote them side by side, or I wrote them vertically. It really didn't matter as much. When you're using elimination, they must be lined up vertically like this. And notice what we were talking about on the left side. My x's are lined up vertically, my y's are lined up vertically, constants are lined up vertically. Both equations are in standard form. Ax plus by equals c. So if you're going to use elimination, notice there isn't a variable that could be easily isolated here. When we were talking about substitution and you were looking for something that would be easy to isolate, that's when you want to use substitution. A problem like this is not going to be fun to use substitution for because you're going to have to isolate either x or y. You're going to have to divide by something. You might end up with a fraction that you have to plug in. So this type of problem right here is really set up for elimination. It's better to use elimination. You could use substitution, but you don't want to. You want to use elimination when you see this. So I'm going to walk you through the steps now. First thing you want to do is you want to set up almost like you're adding and subtracting everything like that. You're going to end up with addition or subtraction here, here, and here down. Now what you want to look for is a coefficient that's already the same with your variable. Notice here, if I was to add these, I would end up with 8x. If I was to subtract them, I end up with 2x. It doesn't cancel. But when I get here, if I add these, I get 0y, which is 0. It cancels. 0 times y is 0. because I have a negative and a positive, and when I add them, they become 0. If I was to subtract these, I would end up with a negative 12y. Doesn't cancel it. What you want to do is you want to get one of these to cancel without having to do very much work. This one's already set up to cancel as long as I add everything. So I'm going to put my parentheses around the bottom equation, and I'm going to put an addition sign. Now I know I'm going to add this set of terms, I'm going to add this set of terms, and I'm going to add this set of terms. And I'm going to end up with one equation and one variable. So let's do that. We add these, and we end up with 5x plus 3x, which is 8x. We end up with, I'll just put it here so you can see, plus 0y equals, now be careful, these are opposite signs that we're adding here, and so you need to look for the difference between them, and that's going to be 16, positive 16. This right here goes away. You didn't even need to write it. I just wrote it for you this time so you would see what you're looking to have happen. So now we end up with one equation, one variable. We solve for that variable. Divide both sides by 8, and again you should start to be able to do that mentally by now, and x equals 2. Now that you have x, you can do exactly what we did in substitution. You're not doing anything new here. Take x, plug it into one of your original equations, find y. So now, use x to find y. Either equation, doesn't matter. I personally would probably use the second equation in this case because I noticed that there are no negatives. And again, a lot of you tend to make mistakes with negatives right here. That worries me a little bit. I always want to look for the easier of the two. Algebra is hard enough as it is. I don't need to make it more difficult. So I'm going to plug in 2 for x in this equation, and I'm going to solve for y. So 3 times 2 plus 6y equals 48. And again, remember, if you had plugged it into here, you'll get the same answer. It doesn't matter. 6 plus 6y equals 48. I'm solving for y. Subtract 6. 6y equals 42. Divide both sides by 6. Y equals 7. So my solution to this system of equations is 2, 7, x and y. And that's how you would write your solution. Now, you want to check these because you want to make sure you did all this math in here correctly. So you're going to take 2, 7, and you're going to plug it into this equation, and you're going to see if it balances, and then you're going to plug it into this equation to see if it balances. It should balance for both. If it doesn't balance for both, you made a mistake somewhere in here. So let's go ahead and try that. So now we're going to check. And remember, we just check by evaluating with that. So our first equation was 5x subtracting 6y equals a negative 32. I'm going to plug in x and y for x and y here and see if it balances. 5 times 2 subtracting 6 times 7 equals a negative 32. 5 times 2 is 10. 42. We have 10 subtracting 42, which is a negative 32. So negative 32 does equal negative 32, so that one is true. Now I'm going to do the same thing for the other equation because it needs to work for both. My other equation was 3x plus 6y equals 48. 3 times 2 plus 6 times 7 equals 48. 6 plus 42 equals 48. And 48 does equal 48. It was true for both, so I did everything correctly, and my solution is correct. If you got lost anywhere in there, hit rewind now, go back, watch it one more time. Otherwise, we're going to try another one now. Write this down. All right, so again, notice this system of equations right here really is not set up for substitution at all. There is no variable that's already isolated. There is no variable that would be easy to isolate. So this is the type of problem you really don't want to use substitution for. You want to get used to using both depending on the type of problems you're given. Notice standard form, standard form. X's are lined up, Y's are lined up, constants are lined up. This is set up for elimination, so I'm going to go ahead, draw my line, get ready to solve. Parentheses always go around the bottom equation, and now I have to decide, would it be better to add each of these terms to get one of them to cancel, or would it be better to subtract each set of terms? Hopefully most of you noticed subtracting right here. If I take 20x and I subtract 20x from it, I would end up with 0x, which would be 0. Here's the problem with subtraction, and you have to decide right now what's better for you. I'm going to show you 2 ways that you could do this. You choose what's better for you. Do not choose what's easiest. Choose what's best for you. Because every one of you has a different kind of pattern with distributing, and so some of you might need a little extra help here, and that's okay. If you put a subtraction sign here and you leave it as a subtraction sign, you need to remember that you're going to subtract each set of terms. That's why the parentheses are here. You are not just subtracting the first, you're subtracting each set. If you're going to be able to do that correctly, then you can do what I just did right now. And we'd have 20x subtracting 20x, which goes away. Then we would have 3y subtracting a negative 5y. Negative and a negative becomes positive when we multiply those. So we end up with 3y plus 5y, which is 8y, equals, and again, negative times negative, positive. We end up adding these together, and we end up with 80. And we end up with y equals 8 is going to divide into 80 10 times. Okay, that's one way to do it. And if you're really good at all those little details and focusing, that is perfectly fine with me. But if you start making mistakes with these, I strongly recommend you do this instead. So we have the same equations given, 20x plus 3y equals 20. 20x subtracting 5y equals a negative 60. And then what you could do here instead, there's my negative. What some of you might decide to do, make this a positive, but in that case you have to distribute a negative to each of them beforehand. Everything changes its sign. So that negative times the positive became a negative, negative times the negative became a positive, negative times the negative became a positive. I distributed my negative, now I get to add everything. So now I don't have to think about it anymore, I just look at my signs as I go and I just simplify things. 20x and a negative 20x becomes 0, positive 3y, positive 5y becomes 8y, positive 20 and positive 60 becomes 80, and y still equals 10. Okay, either of those works. It's what's best for you. Just make sure you do what's best for you. Now that you have y, you go plug y in to find x. Make sure you're always plugging into the correct variable. Choose either original equation. Again, the top one to me looks better this time because there aren't negatives to deal with, but it's completely up to you. I'm going to go ahead and use the top one. So now I have 20x 20x plus 3 times my y, which is 10, equals 20. 20x plus 30 equals 20. I'm solving for x, so I subtract 30 from both sides. I end up with 20x equals a negative 10. Divide both sides by 20. Be careful here. It's not going to be a negative 2. It's going to be a negative 1/2. And it's a negative 1/2 because 10 goes into 10 once, 10 goes into 20 twice. Now your solution is, make sure you do x first, negative 1/2, comma 10. You have to be really careful that you're showing every step carefully and you're making it obvious where your solution is at the end. Because some of these, as you're noticing, take up a lot of space. And what else you're going to notice is a lot of times some of these numbers aren't as nice and easy as our examples. Let's go ahead and check this just to make sure. Not as easy to check when we're plugging in a fraction, but still important to be able to do. So we're going to check it. We're going to plug it into each equation. So we have 20x plus 3y equals 20. 20 times a negative 1/2 plus 3 times 10 equals 20. Okay, some of you are getting really confused about multiplying fractions there. If you're getting confused about multiplying fractions, remember on your homework paper you should have that little space on the right side for work. I'm going to show it to you right here on the left just so that you can see. Don't get scared of those fractions. Go ahead and just write it off to the side as 1 because now you know what to do. You end up with a negative 20 over 2, or you could have simplified before, and a negative 20 over 2 becomes negative 10. So we have negative 10 plus 30 equals 20, and a negative 10 plus 30 is 20, so 20 equals 20. The first one was true. Now I need to check the second one. Make sure you don't choose the same one twice. So now we're looking at this one up here, and that one is 20x subtracting 5y equals a negative 60. 20 times a negative 1/2 subtracting 5 times 10 equals a negative 60. You already have this answer right there. 20 times a negative 1/2 is a negative 10. Don't do double the work. So negative 10 subtracting 50 equals a negative 60. I'm adding two negatives together. Keep them negative. Add them up. Negative 60 equals negative 60. That's true. I did all of my math correct. My solution is true. Add this to the left side of your notes. It's just talking about what we did right up here with the first two. You're either subtracting every set of terms as you go, or you'd go ahead and distribute that negative and then add every set of terms. Write this down, hit play when you're ready to go through it. You're going to see a lot of word problems that are tied into something like this. And we already talked about it a little bit in substitution also. So we're going to go ahead, just add a little to the left about it. Remember, when you have your equations or your word problems and you go to set up your equations, if you read through this as you were reading it, one is based on how many tickets were sold, the other one is based on how much each of them were. So you're going to have two sets of information, two equations. One equation is based on how much money. And then the other equation the money doesn't matter at all. The other equation is based on how many people. And you're going to see this pattern over and over and over with all different stuff, where you get one that's based on like your coin problems. When you get to them, we'll have some coin problems. How much money is a coin worth? If you're talking about a dime, it's 10 cents, quarter, 25 cents. So you'll talk about how much money each is worth and how much money you have. And then you'll talk about how many you have of these coins. 2 equations, 2 sets of information. Always go identify your variables when you go to set these up. So as I'm looking through it, 292 tickets, and I notice that there are adult tickets and student tickets. And when I read my question at the end, remember that's usually where you can find your variables. How many of each type of ticket was sold? My 2 types of tickets are my variables, and they are adults and students. So I could say A equals an adult ticket, and then S if you want, or again, some of you might not like using S because it ends up looking like a 5. If that happens to you a lot, just look for something else in there like D or N in student. Something that wouldn't be an adult, because D could also be an adult. I'm going to go ahead and use S this time. But if you don't like using it, use something else. Now you're going to set up your 2 sets of information. 292 tickets were sold. Well, the 2 types were adults and students. So my adults sitting in my audience plus my students sitting in my audience are going to equal my 292 tickets. Now that was based on how many. Now my other equation I'm looking at is based not on how many, but on how much each of them was worth. So this is my how many. This one's going to be my how much money. Adult tickets were 3, so $3 for every adult, plus $1 for every student equals $470. Okay, this one right there I'm going to put in a different color because it might not show up as a different color. Remember, that's also a 1. 1 for every adult plus 1 for every student equals 292 people. 3 for every adult plus $1 for every student equals $470. That one and that one, same coefficient. These are not the same. Now I have to decide, is it better for me to add or is it better for me to subtract? Some of you might have already noticed that this number is a lot larger than this in both parts of the equation. If you don't like dealing with negatives, you can rewrite these with larger numbers equation first to avoid negatives. Okay, if you don't like negatives, go ahead and rewrite this now. Write this equation first, write that equation second. 3a plus s equals 470, and then a plus s equals 292. Now everything is lined up for you. If you don't understand what I just did there, all I did was flip these around. So this equation was written first, this equation was written second, because now I notice larger numbers are at the top, and hopefully you've already noticed that these were the same sign, so you're going to need to subtract everything. Right now, I want you to decide if you're going to go ahead and put plus and switch every sign, or if you're going to go ahead and put the negative on the outside and remember to distribute it as you go. Completely up to you. I'm going to go ahead and practice for those of you who are just putting the negative at the outside, distributing it as you go and being careful. So I have a 3a subtracting a 1a, which is 2a, s subtracting s, which is 0, equals, now notice this one when I go to subtract, it's already lined up for me if I didn't have a calculator with me. So this becomes a 10, I have 8, this becomes a 6, and then I subtract 7, that became a 3, 1. So I have 178. Solve for my variable that's left. Divide by 2, divide by 2. I end up with A equals 89. Now that you have your adults at 89, you can find your students by plugging it into either or. But if you notice, this second equation is a lot easier. So you might want to go ahead and do that. So now I'm going to find S. 89 plus S equals 292. I'm going to subtract 89 from both sides. And I end up with S equals 203. Because this is a word problem, you don't want to write it as a point. You want to actually write it in words and label it. And you can always go check. Plug A and S into each equation, and you should be able to check it. We're not going to check it this time, though. They sold 89 adult tickets and 203 student tickets. Now I want you to go back and look right here. When you were here with your two equations, did some of you notice before we went ahead and subtracted that it would have been really easy to isolate the A or the S or even this S? You had three variables that would have been extremely easy to isolate. This is the type of equation where it is 100% completely up to you preference for substitution or elimination. You could have solved this just as easily using substitution because these were so easily to isolate. Could have used substitution because there were variables with a coefficient of 1. So this is one of those cases where it truly is preference. Some of you might just be loving substitution, and when you set this up you saw, wow, substitution, I should use that. Obviously for this homework assignment or classroom assignment, you want to try out elimination because we're practicing elimination. But I really want you to start looking now at what's the easier way depending on the type of equation. And this one, there was not an easier way. It really could have been either or. I'm going to go ahead and work that out now quickly for you, those of you who want to see it. If you want to add it into your notes, if you have room on this page, go for it. If you don't have room on this page, don't worry about it unless you want to go to the next page with it. Alright, so this would be using substitution, if I was going to have used substitution. I would have probably isolated the A here just because it would be easy. But the other thing that I notice is if I isolate the A, I have to distribute now when I plug back in if I was to isolate that A. If I move the A, I'm going to be isolating S, and then I'm going to be plugging in for S, nothing to distribute. So you always want to go the easiest route possible. So now I realized, oh, well, wait a minute. Maybe I want to isolate S, so I'm plugging something in there, and I only have to distribute a 1, which does nothing. So I'm going to rewrite my first equation by subtracting A. I end up with S equals 292 subtracting A. My second equation is still 3A plus S equals 470. This gets circled and goes in for S there. Rewrite it, 3A plus, and now I didn't have anything to distribute. I'm used to writing it in parentheses anyway, just in case, but once I look, I only have a positive here. Nothing's going to change. Now I can just start simplifying. I have 3A subtracting A, which is a 2A. 2A plus 292 equals 470. Now I subtract 292. Some of you might notice this looks very similar to our elimination almost now. And when I subtract those, I end up with 178. And we're back to where we were with elimination because now we divide both sides by 2 and we get adults equals 89. Once you have your 89 for your adults, you can go plug it in right here. 292 subtracting 89 still would have given you 203 students. Completely preference there. There is not a right or a wrong for choosing it. There are some where I would tell you definitely use substitution or definitely use elimination. This is one where it is absolutely your preference. This is example 3. Write it down. As you're writing it down, hopefully you're noticing no easy variable to isolate. So this would not be an equation I would want to use substitution for. It's not going to be easy to isolate any of these given variables. What you might also be noticing, you don't have the same coefficient for x. You don't have the same coefficient for y. If you were to add these, you would end up with 12x plus 8y. Nothing canceled. If you were to subtract these, you would end up with a negative 8x and a 2y. Still nothing canceled. Of course, everything always gets a little more difficult, so now you have an added step. Once you realize, wow, wait a minute, there isn't anything set up to cancel, you're going to have to do something to make it cancel. And it's actually a really easy step because you've been doing this all year, but you need to memorize that this is what you need to do. What you're going to do now is you're just going to look and you're going to say, okay, is there anything that I could multiply this 2 by to get it to be 10? Or is there anything I could multiply 3 by to get it to be 5? And what I notice here is, oh, I can multiply something by 2 to get it to be 10. So I'm going to go ahead and use the rule I learned about equations, which is if I'm going to do something to one part of an equation, like a fraction buster, I'm going to do it to every part of the equation. And I'm going to go ahead and multiply every part of my equation by 5 because then I'm going to have a 10 and a 10. Some of you might even have noticed, oh, if I multiply by a negative 5, then I'm going to have opposite signs and they're going to cancel through addition. And I always like addition, so I'm going to go ahead and multiply by negative 5. There isn't a right or a wrong, but there is an easier. And easier to me, if you see it, is multiplying by the negative 5. So make yourself a note here. You're going to multiply the 2x equation, the whole equation, by 5 or negative 5. Let's go rewrite our equations here. 2x plus 5y equals a negative 22. 10x plus 3y equals a positive 22. So I'm going to go ahead and multiply this equation by negative 5. You can rewrite these in any order, it doesn't matter. You can rewrite these where this equation ends up staying at the top, or you can rewrite it where this equation moves to the bottom. What I'm noticing is that when I multiply by negative 5, this is going to get bigger even though it's a negative, the absolute value of it's bigger, and the absolute value of that's going to get bigger or larger. So it's really up to you how you want to look at it, but I'm going to go ahead and multiply it out and leave it at the top. And when I do that, remember, you're multiplying it to every term. So we end up with negative 10x plus or minus, depending on how you want to put that, negative 25y equals negative times a negative is a positive, and then 22 times 5 is 132. Or, no, I'm sorry, 110. Sorry. I looked at the wrong part of my example. I'm going to just go ahead and rewrite this because I don't want it to confuse you. So I'm going to go like that, and I'm going to rewrite it. So our negative 10x subtracting 25y equals a positive 110. Okay. And you can still keep it as plus a negative, it doesn't matter. The second equation just drops down as it is. Okay, we're not going to change that. Now I have 10x plus 3y equals 22, and I'm ready to decide if I'm going to add or subtract these. Because I chose to multiply the first one by a negative 5, I have opposite signs, so all I'm going to have to do is add each set of terms. If you had multiplied by a positive 5, you would end up subtracting each set of terms. So now I put my parentheses around, and I put my addition sign, and I add each set of terms. First set cancels. Negative 25 and a positive 3 becomes a negative 22. Positive 110 and a positive 22 becomes positive 132. Now I divide both sides by a negative 22, and a lot of you are going to be using your calculator for this because you don't want to waste your time at this point, and you find out that y equals a negative 6. You ended up doing everything the same as the first 2 or 3 examples. The only difference was you had to multiply every term. It's almost, think of it like a fraction buster. If I was trying to eliminate a fraction, I would have multiplied every term by something, eliminated my fraction, and then I would have started over. Same exact idea, except instead of doing a fraction buster, you're multiplying by something that's going to get one of these to be the same coefficient so that they will cancel. Now that I have y, I can go plug it in, and I can solve for x. And you can plug it into either of the original equations. So again, when I go look at my original equations, this one has a negative 22 over there. I might not want to deal with that negative, so I might just go ahead and plug it into the second one. Some other people might say, well, yeah, but this one has a 2, and I like 2's better. Or this one's multiplying by 5, and I like multiplying by 5 better. All different reasonings. Does not matter. Either or should get you the right answer in the end as long as you're doing all of your math correctly. I'm going to go ahead and in this case use, let's use the bottom one, 10x. So I'm going to rewrite my bottom equation to find x. So now find x. And my bottom equation was 10x plus 3, and then instead of a y, I'm going to plug in negative 6. Equals 22. 10x subtracting 18 equals 22. I'm going to add 18 to both sides. I end up with 10x equals 40. Divide both sides by 10, and x equals 4. Now this wasn't a word problem, so I'm going to go ahead and write my solution. X first, y second. Remember, it's not about the order you solved. It's about the variable being x first and the variable y being second. And if I was doing my homework or taking a test, we can even just start trying this mentally to practice solving. If x was 4 and y was -6, 4 times 2 would be 8. 5 times a -6 would be a -30. A -30 and 8 gives you a -22. Same thing, 40 would be 4 times 10. -6 would be -18. 40 minus 18 is 22. As long as those are true, I know that they're right and I can move on. Add this to the left side of your notes. It's just talking about when we're going to multiply one equation to eliminate a variable like we did here. It's when you find no variable with matching coefficients already set up to cancel. And like we did when we walked through it, you just look when that happens and you say, okay, well, notice I can multiply 2 by something to get 10. There was nothing easy to multiply 3 by to get to 5. So you always want to look for the easier. Once you find that value, you multiply that to the one equation, and then you have your matching coefficients. And remember, you can have them matching same sign or opposite sign. Same sign is going to have you subtract here. Opposite signs will have you add there. Once you're finished writing that down, hit play. We'll move on to the next example. Write this down. Like most of our problems in algebra, we learn something and it starts off a little bit easier than it ends up at the end. This is the most difficult that these elimination problems can get in this example. Notice there is no easy variable to isolate, so substitution is out. And then I look and there isn't a lined up coefficient ready to cancel. 4 and 7 are never going to cancel. 2 and 3 are never going to cancel. Now I'm stuck. I have to go to what we just did in the last example. And in the last example, I had to look at this. You always look at your smaller number there and I say, okay, is there anything I can multiply 4 by to get to 7? No, because I multiplied 4 by 2, I'd get 8. Okay. Is there anything I can multiply 2 by to get to 3? No, not really. That's not going to be easy. Now I'm stuck. What am I going to do? Well, I can use the rule that we just applied in the last example, but I can multiply each equation by something to make matching coefficients. So now I'm going to stop and I'm going to think, okay, what numbers could I get to 4 and 7? So I start counting by 4s, let's say 4, 8, 12, 16, 20, 24, 28. Oh, 7 times 4 is 28. If I was to multiply this by 7 and this by 4, then I would have 28 and 28. Or if I was to multiply this by 7 and this by a -4, then I would have 28 and -28. Remember, your goal is get them to be the same or opposite signs so that they will cancel. And then I look here and I say, wait a minute. Here I already have an addition and a subtraction. So they're already set up to be opposite signs. What could I multiply that 2 and 3? Well, let's see. 2, 4, 6. 3 goes into 6. 2 times 3, 3 times 2. I can multiply this whole equation by 3. I can multiply this whole equation by 2. I would have matching coefficients, opposite signs to cancel. Either or works. Again, there isn't a right or a wrong, but there's easier. Easier to me is these are already set up to cancel because they're already a positive and a negative. They're also smaller numbers. So for me personally, I might go ahead and decide to multiply this whole equation by 3, this whole equation by 2. The person who decides to multiply this equation by 7 and this one by 4 or -4 should end up with the same exact answers as anyone who does what I did in the end, as long as you're doing your math correctly. So let's go ahead and try this out. Here's where I see a lot of confusion every year. You are allowed to multiply these by different numbers. You're not picking one number to multiply both equations by. You're picking a number to multiply this equation by and a different number to multiply this equation by to get one set of the variables to match. That's your goal. So you're going to end up multiplying this whole equation by 3, unless you're choosing to do the other way and see if you get the same, and this whole equation, by 2. I was thinking opposite signs, sorry. That is not a negative. Don't put that there. Okay, now you're going to rewrite your equations by distributing this 3 to each term and distributing this positive 2 to each term. My first equation ends up becoming 12x plus 6y equals 42. You want to have a calculator by you so you can just do these really quickly. My second equation ends up becoming 14x subtracting 6y equals a negative 16. So now you have your two equations rewritten, and because you have opposite signs on the variable that's going to cancel, you can add parentheses, and you're going to add every set of terms. 12x plus 14x is going to be 26x. Your 6's cancel. Remember here you're adding a positive and a negative, so you're actually finding the difference, and the difference is a positive 26. Divide both sides by 26, and you end up with x equals 1. Now that you have x, you can plug x into this equation or this equation, doesn't matter. I see a lot of positives here, so I'm going to go ahead and use the first equation. So now find y by plugging in x. So 4 times 1 plus 2y equals 14. 4 plus 2y equals 14. Subtract 4 from both sides. 2y equals 10. Divide both sides by 2, and y equals 5. X is 1, y is 5. So your solution is 1, 5. Now, you can check that by plugging 1 and 5 back in. Let's just do it mentally. 1 times 4 is 4. 5 times 2 is 10. 10 plus 4 is 14. 1 times 7 is 7. 5 times 3 is 15. 7 subtracting 15 is a negative 8. They're both true, so we did it right. The other thing that you could do here, if you wanted, is you could graph each of these in standard form. And if you did, standard form would be intercepts. You would end up finding that these cross at the point 1, 5 on a graph. So that's the way that graphing would look as your answer. Copy this into the left side of your notes. It's talking about what we just talked about. You're multiplying both equations to use elimination. If you can't find one that you can multiply one equation by, you're finding the least common multiple, which is what we did here. The first thing 2 and 3 multiplied to be, or the first thing 4 and 7 multiplied to be. It's not always going to be the number that is 3 times 2 or 4 times 7. Let's say like 2 and 12. Well, 2 and 12 you could have multiplied to one equation. Let me think of one. 4 and 14. The numbers 4 and 14 would have had another number, a least common multiple, that they each go into before 14 times 4. So you don't always just want to multiply by the opposite, or the other number there. You multiply each equation by the number that gives you that LCM, and then you solve using elimination. Write that in. Once you're done, hit play. We have one more example to go over. We're going to work on another word problem. Same exact rules as we've been using with all of our word problems in this chapter so far. Write this down. If you want to try it on your own, or at least try to set up the equations, that would be great. If you want to figure out what to do from there, great. Just hit play whenever you feel like you need me to start explaining it to you. First thing, you're going to read through it, and you notice that we're talking about gift wrap, $4 a package, greeting cards, $10 a package. Probably already identified your variables there. Class is selling a certain number of packages and receiving an amount of money. So your two equations are going to be based on how many, how much. Find the number of each type of package sold. So your two packages were gift wrap and then greeting cards. I don't like G because it stands for both, So what I might do is W for wrap and C for cards. W equals gift wrap and C equals greeting cards. If you were to use G as one of them, that's fine as long as you wrote them out before like we are, because you can always refer back if you forget which one you used it for. But I always try to find something that's not in the other one, so it's very easy for me to identify which is which later. You're going to have two equations. One is based on how much money each thing is worth. So we notice that we have $4 for every wrap plus $10 for every set of cards. And that equaled the total amount of money we made, because this is our money, money, money. So 1,084. For our second equation, we're talking about how many we sold. It doesn't have to do with the money. So it's just our wrap plus our cards equals 205. Okay, this is our equation that talked about how much money. This is our equation that talked about how many. You always want to be looking for that in these types of problems. Several different types of problems out there, but as soon as you see one that talks about money and one that talks about how many, you know you're going to have an equation about both. Now you look, notice this is another one where this right here would be really easy to go ahead and use substitution, either isolate W or isolate C. And we'll work through it after using substitution so that you can see that. But this is also lined up in standard form for elimination. Either or is going to work. This is one of those problems where I'm not going to tell you I have a favorite way, because I think both work perfectly for this. If we are going to go ahead and use substitution, we would isolate one. But for elimination, we need a variable to cancel. When I look there, I notice that I can multiply this whole equation by -4 to get this to line up to cancel, or I could multiply this whole equation by -10 to get this to cancel. I know that when I multiply by values of 10, all I have to do is add a 0. So I'm going to go ahead and multiply everything by -10 just because it seems easier to me. The person who chooses to multiply by -4, nothing wrong with that. Person who chooses to multiply by a +4, nothing wrong with that, but they're going to end up needing to subtract every term. Same thing with a +10. So you have several different options here. Let's go ahead and multiply everything here by a -10. When I do that, I'm going to rewrite the first equation the way it was. 4W plus 10C equals 1,084. My next equation becomes a -10W. Subtracting 10C equals a negative, be careful with that, 2,050, because I'm going to add a 0 to the end. Now I'm going to put parentheses around it, and I have opposite signs, so I get to add everything. When I add this, I end up with a -6W. My 10s cancel. And then when I subtract these, I end up with a -966. I divide both sides by a -6. Notice you should always end up with a positive answer here. My gift wrap ends up equaling 161. Now, because they want to know how many of each package, I need to go plug that into one of these equations. This one looks a lot easier, so I'm going to go ahead and plug it into that one. So now I have W. I'm going to go ahead and say 161 plus C equals 205. I subtract 161 from each side, and I get my cards, which is 44. If I add these two up, I should get a total of $205. If I multiply this by 4 and this by 10 and add those totals up, I should get $1,084. And that's how I would check it. And then I always write my answer in words. So the class sold 161 gift wraps and 44 greeting cards. And those are the packages, not just cards. Greeting card packages. Something along those lines. I'm going to have you just put this in your notes at the end of your notes so that you have something to refer back to this week while you're looking at the different ways of solving systems of equations. We're going to go over all three right now. Once we're done, if I explain one, I'm going to kind of zoom in on one. I'm going to explain it. At the end of explaining it, I want you to copy it down and then hit play when you're ready for me to explain the next one. Main thing you need to remember is that in this chapter we have three ways of solving systems of equations. The first way was graphing. And when we look at graphing, you need to remember that you're graphing each line in one graph or on one graph. You can use intercepts or slope-intercept form. Typically, they're not going to give you something in point-slope form, but if they did, you'd either have to convert it or use that. And your solution is the point where they intersect. Remember, parallel lines are never going to have a solution. Same lines are going to have infinite solutions. One problem with graphing to find answers is it's not always accurate because sometimes you have to guess or estimate a decimal answer. They don't always cross at a perfect integer. Hit pause, hit play when you're ready to talk about substitution. Substitution is easiest when you already have an isolated variable. It's also easy to use when you have a variable with a coefficient of 1 and it's easy to isolate it. So that's when you want to use substitution. Your goal is one equation, one variable. Problems with it, when you have fractions, you need to be careful. You can use the fraction buster. And then the other problem is it's not always set up for it, so sometimes you're going to have to move things around. And remember, if you don't see an isolated variable or a variable with a coefficient of 1, you do not want to use substitution. You might want to write something added to that about underneath this part. We can just add it right now. A coefficient that isn't 1 makes it difficult. So hit pause, copy that down, hit play when you're ready to talk about elimination. Elimination is easiest when everything is already in standard form and when the coefficients are in front of the variables that match. Now remember, matching coefficients are the easy ones to cancel. Those last couple examples are the ones where you have that added step of multiplying an equation or both equations by something. Problems that you're going to run into with elimination, sometimes you need to multiply when we don't have the matching coefficients. You have to be careful about when you're adding or subtracting, and then you have to be careful when you're distributing negatives. Those are the things to be aware of when you're using elimination. We're going to continue practicing all three ways this week. We're also going to practice more with word problems next week. And hopefully you'll start to really see the difference between when you want to use either of these. Copy elimination down, and when you're done, that's the end of the lesson.